Sorry about that. Hello everyone, this is Chapter 5, Section 3, Conditional Probability and Independence. Conditional probability is the probability that one event happens given that the other event is already known to have happened. And it is denoted as the probability of A given B. That's how you would read this, right here. And this is just a straight up and down line, okay? It's the probability of A happening given that B has already happened. Calculating conditional probability would be the probability of A given B is equal to the probability of A intersection B, or A or B, divided by the probability of B. The general multiplication rule says the probability that events A and B both occur can be found by using the general multiplication rule. So the probability of A and B is the probability of A and B, right? Remember this? This is an intersection. Which is the part that intersects, is equal to the probability of A times the probability of B given A. Tree diagram. I like to use tree diagrams a lot because I think they make a lot of sense. A tree diagram displays the sample space of an event or multiple events. So this is flipping all the things that could happen when you flip a coin 2 times. So you have a 50% chance to get a head, 50% tail. Then the second time you flip it, once you get a head, you can get 2 heads. You get 2 tails. 2 tails down here, you can get a tail and a head, or a head and a tail. Independent events. 2 events are independent if the occurrence of one event does not change the probability that the other event will happen. In other words, events A and B are independent if the probability of A given B is equal to the probability of A, and the probability of B given A is equal to the probability of B. If A and B are independent events, then the probability that A and B both occur, is the probability of A times the probability of B. So what's the difference between mutually exclusive and independent, or how are they related? All right, so we know that mutually exclusive events mean that there are 2 events that can never happen at the same time. Think about last section where your Venn diagrams, there were 2 circles and they didn't overlap at all, okay? We know that if 2 events are independent, then the outcome of one does not affect the probability that the other will happen. That's the definition of independent events. All right, so how can we relate these 2 things? So let's choose a U.S. adult at random. Let A be that the person is male, and let B be the event that the person is pregnant. We know that these events are mutually exclusive because they will never happen together. So you have a circle, and there would be people, U.S. adults that are males, and they would be in that circle, and then you would have another circle where you would have U.S. adults who are pregnant. So those 2 circles are never going to overlap. Now let's think about independence. Does knowing that a person is male change the probability of them being pregnant? Well, of course it does. If I know someone's male, I know what the probability would be. So it would change the probability that the person would be pregnant. So that's important right here. 2 mutually exclusive events can never be independent. Okay? Because if you know they're mutually exclusive, then you know one outcome is going to affect the other one. All right? We will do some problems like this. Just make sure you have all these formulas and everything written down, and I will see you in class.